what I'm gonna do now is I'm gonna make a small template to cut and measure here. Now what I'll be needing is to find the center pieces from the center from here to here, here to here, and I need also to push it down in order to cut up to this length. I need both of these to be perfectly aligned like this, not one slightly bent and the other straight. Need them both straight and both separated by around 20 to 21 millimeters, because that's the way it fits from the back. So let's check out the methods of which I can make a profile out of paper. Now, there's the theoretical method and there's the practical method. The theoretical method is, as you can see here, anyone who does engineering design or graphical communication design is very familiar with these, and you get the profile like so, and you can basically cut this and lay it on the pipe and measure it over here. So this is a waste of time in this case, so I won't be needing it. What I'm gonna do is the more practical method. This is a much easier way to go about it and much faster method as well. So what I'll be doing is just taking a piece of paper, folding it like so, and get it to this position. Take a piece of tape to measure, get it as tight as possible. Okay. And get to have it like this. So this is partially the first part of the process. Next thing to do is to round it up with tape. Okay. Make it as tight and as neat as possible. And that's the first piece. Next piece. Now it's better to use tape over paper, because what I'm going to show you, the paper will be torn quite easily. So with this method, we should be just fine. Now, this one's over here, this one's over here. Now I get the tape. This is normal masking tape, by the way. I get this tape to sit a bit above the furthest edge of the profile. Okay. And grab another piece of tape to hold it in position, like so. Next step is to get normal blade and cut along the profile. So what we have here is this template cut along the profile. So it's 100% accurate with regards to the profile. However, I do not have centers. So how am I going to get around it? And that is a simple answer. Take this template out, match it to the way it's bent, make sure you press it as tight as possible on each end, so they have to match from side to side. Now tighten like so, and there you have the center line. Same goes for the other side. Now what you have to do is simple. Take these center lines over here, pair them together. You have this one over here matched to this one over here, and Same is applied on the other side. So you have now both edges, both centers. And voila. Now, dress it again in place. Take a very fine marker and mark points. The harder you press, the more they show. So from here on, this should be good enough. These are the markings. These are the other markings. So from what you see here, it's a pretty straightforward process. You can see clearly if you press it really hard, you'd find the center line from side to side. Now, how am I going to measure the center line of this one? Now what I'll do is I'll put it back up. You see, now this one has to fit from face to face and edge to edge. Get it as neatly as possible to the rim and push it slightly down. Pushing it down like this allows me to mark the first point. Over here, over here, over here, over here. However, I would need to make a straight line from one end to the other. So I'll take the rear part as well, mark them over here. And there I have the markings. So I push this down and I have me the center mark over here and the other one that follows over here. Okay, here I have the marking over there. Now that I have this all marked and ready, what I need to do is match these two markings, one at the center and that matches up clearly. You can see here's the mark and here's the mark. Now I'm gonna cut this part off in order to match the other one that I already placed. I already tried numerous techniques and sacrificed many. As you can see, this one is the previous one I was doing on this end as well, and it's pretty much rubbish. So I had to start all over again. This would be the third attempt. Okay, this is all set. Take this out and we can see where I need to cut. So the tool I'm using is basically this cutter. It just slides down. I gave it an angle. Never changed it for the whole process of cutting this, so I have the perfect angle each time. Now, these are various cutouts from previous experiments. These are the cutouts I've made in order to cut this pipe to get a rough estimate where I need to be. So these are offcuts. So I'm using this piece to raise it up since it's not flat, in order to not interfere with the face, so I won't have a bent pipe. Now the trick is get it as close as possible to here, find the face to match the profile being cut, and then just push it ever so gently to match the markings I made. The rest is down to filing these two over here so they could be as tidy as possible. Notice anything different? 1, 2. There you go. Here are some of the many bits and pieces used for testing, and most of them being mistakes I made along the way due to my inexperience in TIG welding. Now fusion welds will create undercuts during the welding process. This is because the metals are sacrificing some material in order to perform the join. And that is why the filler wire is needed, because it will supply the required material during the welding process, making the bond even stronger. So here's the update. All this is ready and all this is sort of ready. So once I tried to fit it, when I re-welded everything, things tended to warp slightly and this area actually shrunk by a whole inch backwards. So after all this warpage from left to right, I had to cut this piece off, weld the flange on the other side and just have this piece cut off. I extended the piece because it needed to be extended a bit further back, so this one I'll weld it once I get this one finished and everything in place. So this is the last weld for this section, and after that this area from here backwards it should be done. So as far as things go, this is the weld that I'm trying to make. It's not grade A, I know. People who weld professionally will think this is quite crap, but it's as close as I can get after welding for a week with the filler rod. Otherwise, fusion welding I got quite a good hang of it, but this one I'm still trying to get the walk the cup method, but I'm still doing it freehand, so for now this is the best result and I can come up with. Now before I welded this bead over here, I had to spot weld these two parts right over here, this side and on the other side, same thing. This is because once I weld here, the welding tends to pull the faces apart and then this whole flange would be distorted and warped. There has been a lot of trial and errors from what you can see, but this is basically the final piece of this exhaust, and it literally has exhausted me. This is one of the downpipes. Now I've checked that every weld is properly welded. There are no defects in the weld. And sure, it's not as perfect as it should be as in the weld run. However, the most important that it is properly sealed. So the next thing I'm gonna do is cover this all up with exhaust tape. Now I did not bother polishing it since this one's going to be covered. So first thing to do with using exhaust tape is use these gloves, because otherwise the fiber will ruin your day with all the itching. Now I bought me a 10 meter tape. I'm going to use 5 meter on each side, and this one is originally a 10 meter by 2 inch, or in this case slightly over 2 inch, which is roughly around 55 millimeter in width. Okay, so I'll start on by applying it on this piece over here. Now whoever is using this tape, be sure to use these stainless steel cable ties. They will be easily cut off by just bending them, and they will snap on their own, since this is a brittle material. Also, I'm using black tape for the reason that it will get dirty down there, and if it's white or gray, it will show a lot, so black is a bit more discreet. Now, first thing to do is to tighten it as much as possible. Since this is gonna be very close to the bodywork, I must tighten it as much as I can. So this is everything nice and tight. These have been cut off, 1 and 2. Now I left these two to show you how to cut them. They're quite easy and straightforward. Now since stainless steel is brittle when you flex it, it will snap quite easily. So you do this and it will snap right at where it should be. And the unit will stay nice and clean. And after this is cut, there you have it. The most important thing is these to be as tight as possible so they will not come loose. So this is sandwiched between the metal plate, and in between I placed a gasket, this fiber gasket, in order to take as much heat as possible from this piece. So by placing that, I'm diminishing the heat transfer from this to the plate and from the plate to the gearbox. So this will not be affected with the heat transfer which comes from the engine onto the exhaust. So this will be placed here and will hold everything together. So from there on I will move on to the flexibles and to the rest of the exhaust pipe. So for now I will assemble these together, align them and tighten everything in place. What I'm going to work on this piece is placing a gasket for the exhaust from the central pipe to the rear pipe onto the muffler. Now, I got me a gasket like this. This is a 0.8 of a millimeter. And what I'm going to do is I'm just going to place it on this and work it out with a hammer. Okay, and that's the old school version of how to work a gasket. Moral of the story, always make spares. So if I need to place this and something happens to this and it snaps once this is in place, it would be much more difficult for me to hammer it into position once it's on the car than out here. So like this, 2 spare, it won't hurt anyone. It costs next to nothing to do this. However, I could not get these made or bought online since this is a custom built flange so everything had to be made from scratch. Having worked through the night, the exhaust was finished. However, I had to cut and weld the exhaust another 5 times, because each time I welded, the pipes warped just enough to seem out of place. So what I used as a measurement was to fit 2 fingers on each side and fit a finger at the top and one at the bottom. Now I know it's not exact science, but it worked just the same. The only problem was that one of the tailpipe sets was extended by 1.5 mm from the other, but after so many modifications I couldn't care less. The last problem I was faced with was the repositioning of one of the hangers, so that was tack welded in place for it to be welded later on. And once again, the pipe was cut in half for it to be shortened. And in order not to damage the bellows, I had them covered with welding gloves, because they can take an insane amount of heat and provided good protection. And here we have the hanger properly welded, which completed the exhaust. Now here's a glimpse of how the exhaust looks like when fully assembled, although the amount of time and effort has proven to not make sense thinking about it logically. But looking at it now, all I can say that it was worth it.
So if you managed to watch the whole process till the very end without being bored, I salute you and thanks for watching.